All right, so the next two sections, we're going to take a look at writing trig, or complex numbers in what's called trig form. Okay, we've been writing complex numbers in standard form. Okay, so like 2 plus 3i. That's a complex number in standard form. Standard form is fine if you want to add and subtract numbers. If you want to multiply and divide complex numbers, or do any other operations with them, that's not the best form to use. You can use it, but it becomes very time consuming, especially if you want to do something like this. Take 2 plus 3i and raise it to the 8th power. All right? What that would mean is you'd have to write 2 plus 3i, 8 sets of parentheses, and then FOIL each one at a time. That's just not the best way to do it. So if we can write complex numbers a little bit differently, we can do things like this very easy. Okay? And we'll see how to do that tomorrow. But today I'm going to show you how to multiply and divide an easier way. But we will review the old way, and then we'll look at the new way. All right, so in order to write numbers in trig form, one thing we have to know how to do is graph a complex number. Okay, graphing a complex number is very simple. Okay, basically, the real part is kind of like it's your x-axis, and the imaginary part is your y-axis. Okay, but we don't call it the real axis, the x-axis and the y-axis anymore. The real axis is A, okay, that's like x, that's your horizontal, and B, it's the vertical axis, but we're not going to call it the y-axis, we're going to call it the imaginary axis. So graphing A plus BI is just like graphing A comma B. Okay, so when you have to graph a complex number, identify the real part, move that many units on the real axis, identify the imaginary part, and then move that many units on the imaginary. Positive and negative is exactly the same as what you're used to. Okay, no change with that. All right, so let's see if we can graph. Does everybody have the A plus BI and then the arrow, A comma B? Okay. So let's see if we can graph negative 4 minus 2i. Cody, what's the real part with negative 4 minus 2i? Yep, so we're going to go left 4. And then the imaginary part? Just what?
Just 2i.
Nope, not 2i. Negative 2. So remember, the imaginary part is just the number that's in front of the I. Okay, so negative 2. So we just go left 4, down 2. That's it. That's the point, negative 4 minus 2i. Kelson, how would I graph negative 2 plus 3i?
You go left negative 2 on the graph, and then up 3.
So yeah, left 2, and then
Up 3.
up 3. All right, so that's negative 2 plus 3i. So we have about 5i. Yes, okay.
So you double.
Yeah, if you're confused because there's no imaginary part, you can, there's no real part, you could think of it like this. 0 plus 5i. So you don't go left and right, you just go up 5. And then the second one, this is what I was thinking, if that doesn't have an imaginary part, just put plus 0i. So in this case, you just go right 6. That's how you graph a complex number in the complex plane. Any questions on that? Okay, so that part's pretty straightforward. All right, so absolute value. How do we find absolute value of a real number? How do we define it? Yeah? The distance of a number from 0. So when we're looking at a plane, we don't really call this part where everything starts from 0. What do we call that? in a plane? Yep,
Point of origin.
it's the origin. So to find the absolute value of a complex number, you're still finding the distance from the starting point, but we don't call it 0, we call it the origin. So that would be the absolute value of negative 4 minus 2i. Just find the length of that segment. And how do you think we could find the length of that segment? Yeah, just make a triangle out of it. One side's 4, one side's 2, and that's it. Okay, just use Pythagorean theorem. So the distance from the origin, that's the absolute value. And what I've done right here, this is the Pythagorean theorem. A squared plus b squared, and then take the square root. So it's just the Pythagorean theorem. And when we start writing complex numbers in trig form, this is one of the calculations you have to do that. Okay, you have to be able to find this distance. And that distance is basically going to have to do with this. It's going to have to do with the radius of a circle. Okay? So all we really have to do is know the Pythagorean theorem, and we can find that distance. Okay, so let's try to find the absolute value of 3 plus 4i. So it's the square root of
9 plus 16, which is 25.
So 3 squared is a squared, 4 squared, that's b squared. 9 plus 16, somebody just said that. Add them up. You get square root of 25, 4, 5. That's the absolute value of 3 plus 4i. Okay, any questions on that? Now the square root doesn't always come out nice. If it comes out to something like square root of 20, you do want to reduce that as much as you can. What would square root of 20 reduce to? 2 square roots of 5. Okay, so things like that might come up as well. But any question on how to find the absolute value of a complex number? So it's maybe a different concept, but the technique to do it is something you've done tons of times, just Pythagorean theorem. All right, so now let's look at how we can write a complex number in trig form. So normally when I write a complex number, I use a and b. I'm using x and y here because I want you to think of it as like x is horizontal and y is vertical. So it's probably easier just to remember. And you can put y times I or I times y. I think I usually put the I after it, but I put the I before it because of the answer that I'm going to get. And this is how the book does it as well. All right, so what we're trying to do is when we write a number in trig form, okay, we're trying to find two things. We're given an x and a y. Okay? We want to get rid of the x and the y. And we want to turn it first into an r. So we want to find r, which is just like finding the absolute value. It's the Pythagorean theorem. And the other thing we want to find is this angle right there. It's the angle between the radius and the x-axis. Now I've drawn this in quadrant 1, but it could be in quadrants 2, 3, or 4. And we'll talk about that after, but let's just do it for quadrant 1. So I want to use two different trig functions. Anybody know what trig function I could use that would involve this angle, this side, and that side?
Sine.
Yeah, what would you write down? The sine of?
Sine of theta equals y over r.
Yeah, sine of, so let's start with that one. So sine of theta.
Please excuse this interruption.
All right, so Kevin just told us, can you say that again? Sine of theta equals?
Y over r.
Y over r. Okay, sine of theta equals opposite over hypotenuse. And now I want to get y by itself. So how would I get y by itself there? Multiply by r. Okay. Now what I've just done is I created a formula for y. R sine theta equals y. Okay. Now I also need to create a formula for x. What function would I use? I wouldn't use sine. I'd use cosine. And what would the cosine of theta equal? Yeah, equal x over r, adjacent over hypotenuse. And I'm going to do the same thing. I want to get r by itself again. So multiply both sides by r. And now you have another formula. R cosine theta equals x. Now basically what we're going to do is we're just going to substitute those two formulas in. Wherever you see an x, you're going to change x to r cosine theta. And wherever you see a y, you're going to change it to r sine theta. And that's going to give us the trig form of a complex number using just r's and thetas. We're not going to have any x's and y's. Okay? So if you make that substitution, instead of x, you would have r cosine theta plus, the I stays right where it is, times y, which is r sine theta. Now, there's something I can do to simplify that a little bit. What does each term have in common there for a factor? It has an r. So what can I do with that? I can factor it out. So what I've done is I factored an r out of the first term, and I'm left with cosine. And I factored an r out of the second term, and I'm left with I sine. And that is the trig form of a complex number. Okay, so if you were writing something in trig form, okay, a final answer would look just like this. 2 cosine 10 degrees plus I sine 10 degrees. Thank you.
Yep.
Okay, and that's it. That would be a final answer to a problem. You don't do anything with that. If you were to plug in the cosine of 10 on your calculator and then multiply it by 2, and then plug in the sine of 10 on your calculator and multiply it by 2, you would be changing it from trig form back to standard form. So that's why we don't want to do it out. You leave it just like this. Okay? If they ever ask you to change it back to standard form for some reason, then you do exactly what I said. Type in the cosine of 10 on your calculator, multiply it by 2, plug in the sine of 10 on your calculator, and multiply that by 2. The first part is the real part, because there's no I. The second part is your imaginary part, because that has the I. So to use that form, you need to know two things. In your problem, you need to figure out the radius, which we just talked about with absolute value. It's the calculation you have to do. And you have to know the angle. So r is the distance from the origin, or the absolute value. And theta is the angle with the positive x-axis.
How did you get the 10 degrees?
That's just an example.
All right.
Okay, so next we'll look at how, just to make sure we remember how to find r, and then also how to find theta. All right, so how do you find the distance from the origin that a complex number is? Yep.
Pythagorean.
Yeah, you use the Pythagorean Theorem. Okay, that's all you have to do to find the distance from the origin. So let's pretend that that's the point x plus iy. That's an imaginary point. And I want to convert it to trig form. Okay, so the first thing I'd have to do is find the radius. Okay, this is the radius. Well, just make a triangle out of it. That's x, that's y, and then you can just write r squared equals x squared plus y squared. Okay? I'm going to write that a little neater on the next page. So if you just want to watch this part, that's fine. And besides r, what's the other thing I need to find? Theta. Now, how would I find theta using x and y? Because you're going to know those two numbers. What trig function? Yeah. And what would you write down? Tangent of?
Tangent of theta equals y over x.
Yep, tangent of theta equals y over x. And now how would we get theta by itself? Kev, we can't multiply because it's a function. What do? Take. Take the inverse tangent of what's on the left and the inverse tangent of what's on the right. So theta is the inverse tangent of y over x. So to find r, you use the Pythagorean Theorem. And to find theta, you do inverse tangent of y over x if you're in quadrants 1 and 4. The reason why it only works in quadrants 1 and 4 is because when we studied inverse tangent, we learned that inverse tangent always gives you an answer between negative 90 and 90. Well, negative 90 to 90 only covers quadrants 1 and 4. Okay, so just using this formula would never give you an answer in quadrants 2 or 3. If you want an answer in quadrants 2 or 3, it's a small adjustment we have to make. If you're doing it in radians, it's pi plus the inverse tangent of y over x. Okay, but the only time you have to do the pi plus is if you're in quadrants 2 or 3. If you're doing it in degrees, it's 180 plus. Okay, it's a little bit different formula to find theta, depending on if you're in quadrants 1 and 4 or 2 and 3. Now, that still doesn't cover everywhere that an angle could be. Where else could an angle be besides quadrants 1, 2, 3, or 4? It could be on an axis, and the problem with these formulas if you're on an axis is, let's pretend that's a unit circle. What's the coordinate of that point? 0, 1. What would happen if you try to plug an x value of 0 into one of these fractions? Right, you'd be dividing by 0. So if you're on an axis, you just have to memorize it's one of these 4 answers. 0. Straight up would be 90 to the left and down. All right, so if you're on an axis, that's a quadrantal angle. You just have to memorize it's one of those 4 answers. Okay, or in radians, 0, pi over 2, pi, or 3 pi over 2. Okay, it's easy to know when you're on an axis because what number is always in the coordinate somewhere? You're always going to have a 0. 0 comma something or something comma 0. So anytime you have a 0, your answer is one of these 4 numbers for the angle. Okay, that's the easier case. If you don't have a 0 in your coordinate, then you've got to go through this inverse tangent y over x stuff. So any questions on how you find theta if it's in a quadrant or if it's on an axis? Okay, so now we'll practice changing a number from standard form to trig form, and then after we know how to do that, I can show you what trig form is useful. Why is it so much faster to do things in trig form? Okay, first thing I like to do is graph it. Why? Because I need to know what quadrant I'm in. Right, so just a quick sketch. How would I sketch the point, negative 2 plus 2i? Yeah, and how do you get there?
Back to,
Would-
left to.
Yeah, left 2, up 2. Right, so good enough. Left 2, up 2. Regardless of the quadrant I'm in, to find r, it's the same in every quadrant. What's my radius going to be here? Yeah, it's going to be the square root of 2 squared plus 2 squared. So that's 8. But then you have to reduce the square root of 8 to 2 root 2. so that's half of what you need. What else do you need? You need theta. What is the formula for theta? We can do it in degrees for the quadrant we're in. Yeah.
180 plus the inverse tangent of y over x.
180 plus inverse tangent of, what's y in this case? 2. Y is your imaginary. And what about over x?
2. -2.
-2. Okay, in this diagram, the 2's are distances. I didn't put the negative because it's represented as in the image as going left. Okay, but when you do y over x, you've got to use the 2 numbers in the coordinate. Okay. All right, so that's really the inverse tangent of what number?
-1.
Yeah, so I'll just, when I type it in, I'll just do 180 plus inverse tangent of -1. I don't know. Inverse tangent of -1. And if I wanted radians, I could leave it just like it is. But I wanted degrees. Well, let me do it in radians to show you. If you do it in radians, you're going to get a, well, if you did it in radians, first of all, you'd have to do pi, right? So if you do it in radians, you're going to get a decimal that I don't think you're going to recognize, 2.356. But if you do it in degrees, you're going to get an answer that you will recognize. Let me just change to degrees. It's going to be 135. Okay? So now, if you wanted to change that to radians, I can tell you, I know pi over 4 is 45. That's triple pi over 4 in radians. So looking at 2.356, I don't recognize it, but I do in degrees, and then I could change it by hand to radians if I need to. Okay, so always do it in degrees first. And in this case, I'm just leaving it in degrees. Okay, so 135 degrees. Okay, so those are the 2 things we need, but that's not the answer. We have to write it in the format r cosine theta. So r cosine theta plus I sine theta. And leave it just like that. That's the final answer. If you took the cosine of 135 and multiplied it by 2 root 2, you would get -2. If you took the sine of 135 and multiplied it by 2 root 2, you would get +2. So if you did that out, you would be changing it back to what we just had. So I guess it's a good way if you want to check your answer, type all this into the calculator and see if you get back the original problem.
When
But
you type in calculate, what you put?
you type in this part first, 2 root 2 times cosine 135, and then you don't even type the I in. You just add that yourself. Just type 2 root 2 sine 135 and make sure you get 2 for that one. Hey, any questions on that? All right. So where trig form comes in handy is multiplying and dividing complex numbers. So I'm going to review how we used to divide complex numbers the old way. And then I'm going to show you how we do it the new way. Okay, I would still make sure you know how to divide complex numbers the old way, though. That's important to know for this week. Okay. Does anybody remember when you have a complex number? And this one's not even as bad as it could be. I could have done a complex number in the top and the bottom. Okay, I only put one in the bottom, so this one's actually a little easier. But what do you multiply top and bottom by to divide this? Yeah? The conjugate, which is 5 minus I. Now the top isn't too bad to do out because it's just a single number times a complex number. There's nothing to FOIL in the top, just a single distributive. 3 times 5 minus 3 times I. But now, in the bottom, we have a complex number times another complex number. So that has to be FOILed out. So we start with 5 times 5 which is 25. And then 5 times negative I, minus 5I. And 5 times positive I, plus 5I. And the last part, positive I times negative I squared. Now that minus 5I plus 5I is going to always cancel when you have conjugates. But if you were multiplying like 2 plus I times 9 minus 8I, it's not usually going to cancel out. Okay? All right, so now on the top we can just keep the same for now. In the bottom, we have 25 minus I squared. What is 25 minus I squared? 26, because it's 25 minus negative 1. Okay, so it's 25 minus 1, which is 26. And that still isn't really the final answer because you need the real part and the imaginary part separate. What's the real part here? It's 15 over 26. And what's the imaginary part? Yeah, we usually just put the I right in front. If you put it in the numerator, that's also fine. But that's how you have to divide complex numbers in standard form. So you have to find the conjugate, FOIL it out, combine like terms, change I squareds to negative 1s, combine like terms again, and then separate it into real and imaginary part. There's a lot easier way to do this if we use trig form instead of standard form. Okay, but any questions on the old way? Okay, we did that probably way back at the beginning of the year. All right, so let's suppose we have two complex numbers. Okay, I'm just going to call them Z1 and Z2. And each complex number has its own radius. They could be different, they could be the same, doesn't matter. But the first radius is R1, the second radius is R2. And each complex number has its own angle. Z1 has an angle of theta 1. Z2 has an angle of theta 2. So when we do an actual problem, it's going to look more like this. Let me find one. Like this. You'll be given the radius, and you'll be given the angle. Okay, that. Or if you're not given it, you'll have to find it. Okay, the way we just did in the last problem. Okay, if you want to multiply two complex numbers together, okay, instead of all the foiling and the I squareds and the combining like terms, the only thing you have to do is take R1 and R2, multiply them together, take theta 1 and theta 2, and add them up. That's it. That's all you have to do. Whatever R1 and R2 is, multiply them together, write that down. Whatever theta 1 and theta 2 are, add them up. Write that down. And that's the whole thing when you multiply complex numbers in trig form. Now, dividing numbers in trig form follows kind of the same pattern. Anyone think they know what we would do with R1 and R2 when we're dividing? We would divide them, and we would subtract the angles. Okay, so to divide complex numbers in trig form, instead of finding the conjugate and foiling and doing all that stuff we just did, this is all you have to do. Divide R1 and R2, subtract theta 1 and theta 2. Again, I'm assuming that R2 is not 0 because you can't divide by 0. Okay, so it's 4 operations we're going to learn how to do in trig form. Multiply, divide, raise things to powers, which will be tomorrow, and the opposite of raising to a power is taking a root. So we're going to learn how to do powers and roots tomorrow. These are I think the easier ones. Raising to a power is also very easy. Taking a root is not as easy. There's a pattern to do it. There's a formula you follow. You just have to learn how to do it, and it's the same thing every time. But it's a little tricky at first. All right, so what I've done here to save a little time on this one is I've given you two complex numbers. In fact, -2 plus 2i, I think that's the one we just did. -2 plus 2i. So that's the radius. And that's the angle, 135, which was, I think it was like 2.36 in radians. Yeah, about 2.36. So the first one is one we just did, except it's in radians now instead of degrees. That's fine. Okay, and the second one, I don't think we did this one, but I'm giving you the radius and the angle. Okay, and I want to do two things with these complex numbers. I want to multiply them together, and I want to divide them. And I'm saying to leave the answer in trig form. So when you're done, don't distribute what's on the outside and take the cosine and the sine. Just leave it. Okay, so let's start with z1 times z2. What would my radius be when I do z1 times z2? Yeah, it's 5 times 2 square root 2. That's 10 square roots of 2. And then we're going to put cosine something plus I sine something. What do I do with my 0.93 and 2.36? Just add them up. 0.93, 2.36, 3.29. And that's it. That's all you have to do to multiply two numbers and leave the answer in trig form. If they wanted the answer in standard form, you put your calculator in radians and type in 10 root 2 cosine 3.29, write that number down, and then type in 10 root 2 sine 3.29, write that number down, and make sure you put an I after it. Okay, there will be some on the test you have to convert to standard form, but we're going to practice doing more of that tomorrow. That's why I'm not doing it right now. All right, z1 divided by z2. Okay. What's r1 in this case? What's my first radius? So I'm going to take 5. And what's r2? 2 square roots of 2. Okay, we can't leave our radius like that. What's wrong with it? We can't leave the square root in the bottom. So how do we fix it? Multiply top and bottom by square root 2. So we get 5 square roots of 2 over 2 times square root 2 times square root 2 is 4. Now, if somehow, let's say this top number was an 8, then you would be able to reduce. Okay, always reduce if you can. But 4 doesn't divide into 5, so I can't. So that's my radius. 5 root 2 over 4. Okay, cosine. What do I do with my angles this time? Okay, so I'm going to subtract them. 0.93 minus 2.36. Now I got negative 1.43. And that answer is fine if the problem says you can leave your answer with a negative angle. But what's one way you can deal with a negative angle and make it positive? Like for example, if I had the angle negative 45, what's that the same as? I can add 360 if I'm in degrees. I'm in radians here. So I could add 2 pi. So I could take negative 1.43, and as a decimal, what's 2 pi? 6.28. So that's exactly the same as 4.85. 4.85 135 plus I sine 4.85. That's one way to deal with a negative. Okay, so both of these answers are the same thing. Let's see, they're both correct. Okay, I'm just showing you the different ways you can write it in case you get a certain answer on the test and it doesn't match the answer that I have listed. Because there's lots of ways you can write answers. Okay, does anybody remember what the difference is between the cosine of an angle and the cosine of the negative angle? Well, let's think about it as a picture. Okay, somebody give me actually I'll make up an angle. Let's do 45 degrees, okay, just because that's an easy one. Okay, and let's say the coordinate of it is xy. What would the coordinate of negative 45 degrees be? It would be x negative y. When you're taking the cosine of an angle, what letter is it? If we're doing unit circle trig. It's the x value. So what would be the difference between the cosine of positive 45 and the cosine of negative 45? It's the same thing. So when you have a negative and you're taking a cosine, the negative doesn't matter. You can just get rid of it. Right? Try it. Try taking the cosine of 10, take the cosine of negative 10 on your calculator. You're going to get the same answer. Right? So what I can do is get rid of the negative. So it's just 1.43. Now, let's look at the sine. What's the sine? What letter is that? It's the y. What's the difference between the sine of 45 and the sine of negative 45? They're opposites, right? All that you happened is you put a negative in front. So when you do sine, you can't get rid of the negative, but you can move it in front. Okay, that's what happens with sine. So like if you took the sine of negative 10 and the sine of positive 10, you'd get the same number, except one's positive, one's negative. Right? So when you have a negative on the sine, you can move it in front. So all of these answers are correct. I would say most often you won't see answers written the first way, because they'll get rid of the negative on the angle. It's just how did they do it? Did they add 2 pi? Or did they just take the negative away from the cosine and move it in front of the sine? But if you're not sure, you can type any of those in and you'll get all the same thing. Thank you. Any questions on dealing with a negative? Dealing with a negative usually doesn't come up when you're adding. Because if you started with 2 positive numbers and you add them, it's still going to be positive. But if you start with 2 positive numbers and subtract, depending on which one is bigger, you do get a negative. All right, let's try this one. What's a little different about this one that it would take a little longer to do? The numbers aren't in trig form. But negative 2 plus 2i, we've done this one a couple times. Okay? Let's do it in degrees, okay? Because we just did one in radians. Let's do it in degrees. So z1 is 2 root 2. What was the angle when we did this one? 135 plus I sine 135. Okay, so that's half of it. And now the other one, I don't think we've done yet, so we need to figure that one out. What quadrant am I in? 4. Positive x, negative y. It doesn't have to be to scale. Just put a dot somewhere in quadrant 4. And r squared will equal what squared plus what squared? 3 squared plus 3 squared root 3. Okay, what's 3 squared? 9 plus, now to square this, square the first term. What do you get when you square that? Times, and now square the second term. What's 9 times 3? 37. So what's my radius? 6. It's the square root of 36. So my radius is 6. And now I need my angle. What's the formula to find theta in quadrant 4? Inverse tangent of what's y? Negative 3 square roots of 3. Yep. And what's x? 3. So really it's just the inverse tangent of negative square root 3. Okay, which anytime you have square root 2s and 3s, that's a suggestion. You're usually going to get a nice answer. So we shouldn't have any decimals here. So inverse tangent of negative, was it square root of 3? 3. We get negative 60, or we can deal with that negative right now and add 360 to it, which would be what? Yeah, 300, right? 300? It's up to you. We could just, because that's not the final answer to the problem. So I think I'm just going to leave it as negative 60, because why bother? But if you wanted to change it, you could. Now we're going to add them and subtract them, or multiply and divide them. Okay. What would be my radius when I do z1 times z2? 12 square roots of 2. And what would be my angle? $75. Yeah, just add those angles up. 135 minus plus negative 60 is 75. All right, so that's the answer when you multiply them. And what about our radius when we divide them? Square root 2 over 3. Yep. So that's my radius. And this is why I kind of changed my mind about changing the angle to a negative, fixing it. Because what's going to happen here when you divide? What do you do with the angles? You subtract them, so what's going to end up happening? So you're going to subtract a negative anyway, so this won't even matter, because it's going to turn to addition. So what's 135 minus 60? 195. Had you fixed that angle and made it 300, then you would have done 135 minus 300. It would have become negative again, and you'd had to fix it anyway. Okay? But the way we did it, we don't have to. Okay, so that's writing complex numbers in trig form. And the nice thing about it is everything in the section is connected. The graphing, the absolute value, it's all, you have to do both of those when you write a number in trig form. Okay, so the homework on 450 is 1 through 3, 5, 8, 11 to 14, 17 to 20, and then 33, 34, and 37. Okay, some of them are just graphing, so they're very quick. I think only the last few problems are converting a number into trig form and then multiplying and dividing. Okay, so we'll look at that tomorrow. On Thursday, we'll do section 8.4. And then on Friday, you guys will have a little under 2 hours to do the test. The test is just on what we've done this week. And I will be after school on Thursday.